All right, welcome back to Logic. My name is Tom, and in this unit, we will talk about valid forms of inference. And basically, what we're talking about with valid forms of inference is basically just making inferences based on all the rules that we've learned up till now. We're talking about conjunction, disjunction, conditional statements. And then we just kind of give names to the rules the way in which when we find specific kind of premises that have these, we can make certain kinds of inference from them. And here we're just kind of going over the basics. So let's start off with modus ponens, modus tollens, and hypothetical syllogism. All of these deal with conditional statements. Now, if you remember, a conditional statement is something like, if it is raining, then the ground is wet, right? And so the antecedent is it is raining, and the consequent is the ground is wet. And we know that if it is raining, given that condition, that this consequence will follow. It has to be the case, right? If that is a valid or a true conditional. Okay. And so what modus ponens is probably like the simplest one. The way modus ponens works is that if you have that kind of conditional, if it is raining, then the ground is wet, and you know that it's raining, then you can make the inference that the ground is wet. Right. So in logical notation, it would be something like, R for it is raining and G for the ground is wet. Right. So if you'd have R horseshoe G and then R, then you can infer G. Right. That's the way the rule of inference works. So it's pretty simple there. Notice that we use modus ponens all the time, like this. Conditional statements like, if the light is red, then you must stop. The light is red, therefore you must stop, right? We kind of make these kind of inferences all the time. Now, modus tollens has to do with denying the consequent, right? So let's say it's true that if it is raining, then the ground is wet. But you look out and the ground is not wet. Then you can infer that it is not raining, right? So in this case, it would be if R, then G, not G, therefore not R, right? You can deny the consequent, but not the antecedent, not the first statement, right? Because if you said it's true that if it's raining, then the ground is wet, and you said, well, it's not raining, therefore the ground is not wet. That's not quite right, because the ground could be wet from something else. Someone was spraying a hose or something, right? There's other reasons why the ground could be wet. Nonetheless, it doesn't take away from the truth of the statement that if it is raining, then the ground is wet. All right, so that's the way modus tollens works. It's just kind of the case in which you deny the consequent. Therefore, you can infer the denial of the antecedent. That's the way it would kind of function in logical language. Now, hypothetical syllogism is basically when you have two conditional statements, you can kind of skip from the antecedent of one to the consequent of the other, right? How does this work? Well, it's basically, you have something like, if something is human, then that thing is an animal. If something is an animal, then that thing is mortal. Therefore, if something is human, then it is mortal, right? You have a middle term there, where the consequent of the first statement is the same as the antecedent of the second statement, right? And so it's a syllogism that allows you kind of like move from the antecedent of one to the consequent of the other, right? So that's the way hypothetical syllogism works. If you have those two kind of conditional statements that line up like that, then you can infer a further conditional from it. So in my example, right, if something is human, then it is an animal. If something is an animal, then it is mortal. From that, you can infer if something is human, then it is mortal, right? Animal is the middle term there, and that allows you to kind of skip that middle term and make a conditional that combines those two conditionals in a certain sense. And then the last rule here is disjunction elimination. And this one should be pretty intuitive, right? Given a certain disjunction, an either or statement, if you deny one of the disjuncts, then you can infer the other one, right? So if you have a disjunct like either it is rain or either it is um, sunny outside or it is cloudy, right? And you say it's not sunny outside, therefore it is cloudy, right? That's disjunction elimination, right? Given an either or statement, which says that at least one of them must be true. If you can say that one of them is false, then you have to say that the other one is true. Very simple. Um, uh, um, so that's the way disjunction elimination works. Now, um, some of this might sound a little jumbled. I'm using terms like disjunct and antecedent and stuff a lot. Um, but the book goes through it pretty quick or pretty clearly, and really the way to get these things is to do exercises, and that's why there's kind of valid forms of inference assignment this week that will help you kind of do some translations and kind of get more familiar with how these rules of inference work. And this will be the last kind of part of the formal logic unit. There'll be an exam after this, so and so that's pretty much it. It's really about practice. Going through it and doing all these exercises should put you in a place that you know what you need to know for this unit. So um, that's it for this unit. I will be talking with you soon.